Today we'll cover nil slices versus empty slices in the Go programming language. So when I was a Go newbie a few months ago, I ran into an interesting style recommendation. So let's go to the code. So what I was trying to do is basically create an empty slice. So let's create an empty slice string. And then I saw this squiggly line and my IDE was telling me that I should replace this with a nil slice. And this didn't quite make sense to me in the first. How can a nil slice be better than an empty slice? With nil, you have to check for nil. You might have a null pointer exception. You have all kinds of headaches. Why would I want a nil slice? So eventually I tracked it down to this recommendation on the style guide, which basically said that a nil slice is pretty well behaved. So let's go over the code and see the actual differences between a nil slice and an empty slice. Let's jump into the code. So I have a function here that creates an empty slice, a nil slice, or an empty slice based on this use preference constant, which is true by default. And I'm going to give a link to this code at the end of the video. So basically this is the difference between, this is the main difference between an empty slice and a nil slice. A nil slice will compare to nil and return the slice as nil. So let's go ahead and run this and you'll see slice is nil being printed down here. However, if you use this notation and actually try to print the slice, it'll print like an empty slice, which is exactly how an empty slice would print. Appending works just fine. We can append to a nil slice. We can for loop a nil slice just fine, and it will not enter this loop. And if we get the length of a nil slice, the length is 0. And this was the thing that kind of confused me the most, is passing by pointer. So I'm taking a nil slice and I'm passing a pointer to it, to this function. In this function, I get a pointer to the nil slice and then I dereference a pointer. Now, if this was an actual null pointer, we would crash at this point. But a nil slice is not a nil pointer. A nil slice is still a slice. It has the slice wrapper around it. It has a slice header. So it is not a nil pointer. So that's the main thing to get your head around too, is a nil slice is still a slice. It is not a nil pointer. So if I pass it over here, I can append to it. And then when we step out of the function, our slice is updated. So we can see the slice that we updated inside this function. So we started out with the nil slice, so we added something to it, and then we got a new length of 1. Now, if this was a null pointer, we would crash. So here, this is a null pointer, right? Because I'm using the pointer notation here. So this is actually a null pointer, not a null slice, a null pointer to a slice. And if we do this, we will actually crash. So let me demonstrate this crash here. So if I say null pointer is, we're going to be using null pointer. And let's run this again. And you'll see we actually crash here at line 60. And just for demonstration's sake, let's just say null pointer false. And let's rerun this again just so you can see what everything that returns. Slice is nil, prints empty. We appended something to it. Length works fine. We pass it by pointer, and then we get it back with a size of 1. So let's now basically, instead of a nil slice, let's use an empty slice and see how this output is different. Let's rerun this. And basically all of this is the same. The only thing is different is the slice is not nil anymore. This comparison returns false. Well, thanks for watching, and I hope you've learned something. I sure have.